see Lindelof videos, calculus, the use of the product rule. So let's see if we can get through this. Here's what you have to start with the product rule. It says, the product rule says this: if we want the derivative, the slope of a function, d dx, of some function times another function, there is this rule that we can use. So the first thing we need to do is kind of memorize the rule. And the rule just says this, that derivative is f of x times g prime at x plus g of x f prime at x. So first off, memorize the rule. It's going to help a ton. Second thing you need to do is kind of make a list. So let's try this a little bit. Let's try a pretty easy example here. So let's take this. We have our function f of x. And our function f of x is equal to negative x cubed times 3x to the fourth minus 2. You might be asking this question, well, Charlie, can I just distribute this through and then take the derivative using sum and difference rule? In this case, that would be really easy. Sometimes it's not as easy, so there's another way to do it. So let's try that. This is what I'm going to do. I'm going to forget about the fact that this function is named f of x, because that's just coincidental. What I am going to do is take my rule here and see how this applies. So if you don't mind, I'm going to name this first part of this function, I'm going to name this my f of x. And by the same reasoning, I'm going to name the second part of it g of x. And you're like, Charlie, I already have an f of x. These two are not related, just if you can let that be okay for a minute. And then I'm going to start collecting my pieces. I need an f of x, so I already know that f of x is equal to negative x cubed. So I have my f of x. I need an f prime at x. F prime at x is the derivative of this. So using the power rule, we know that that's 3x squared. It also says that we need g of x and g prime at x. So my g of x is the second function, which happened to be 3x to the fourth minus 2. G prime at x is equal to 12x cubed, isn't it? So from here, I'm not going to, I have this thing beaten here, but if I get this thing done, if I get this thing memorized and I get my list, all I have to do from here is just fill in the blanks, right? So it says that we need f of x, which is negative x cubed, isn't it? I'm just taking it from my list here. So negative x cubed times g prime at x, and g prime at x we said was 12x cubed, right? And then just go up here and take a look. This plus sign right here is this, and I'm just following the pattern that I was supposed to follow. Then my instructions up here for our rule says that we take g of x, 3x to the fourth minus 2, times f prime at x. So that's all I'm doing here is my f prime at x times negative 3x squared. You see I put this in parentheses because I was afraid if I didn't it would look like I was subtracting this. So I was just trying to be a little bit careful. I am going to go ahead and simplify. And I have negative x cubed times 12x cubed, which is negative 12x squared, right? Here I'm going to distribute this way. It's exactly the same thing, which gives me negative 9x to the sixth, isn't that right? Plus 6x squared, right? From here, we can take a look. Is there anything else that we can simplify? All I'm asking you to do is simplify stuff that's easy to simplify. We have x to the sixth here and x to the sixth here. We have negative 12 of them, negative 9 of them. That gives us negative 21x to the sixth, doesn't it? Plus 6x squared. You could factor more out, but I don't really care. Remember that the f of x that we had up here, I just left it in white because I wanted to show you this. And I'm looking for f prime at x, and this is the derivative of that whole thing, isn't it? All right, so I hope this is helpful. This is something you can really do. Go back to the idea. First, memorize the product rule. Memorize the rule. Second, make a list. And from there, it's just FITBA, right? Fill in the blanks. So I hope this is helpful. If you have any questions or comments, let me know. Hey, if you haven't already subscribed, please do. Thanks.